So next question. So let us go for the next question. That is question number. Yeah. So question is seventh one. A hollow cylinder like this is there, okay, of radius r, rotates about axis which is vertical. Okay, so vertical axis, we don't know whether it is side or middle passing through the center. No. Let us see. A block remains in constant with the inner wall of the frequency of the rotation is f hertz. Okay, the block is there on the inner wall. So this is the block, okay. Now, frequency of rotation is f hertz. That means the hollow cylinder is revolving, okay, but falls at lower frequency. Okay, that means this block is there, right, inside this particular cylinder. It will fall down, that means to its surface, when frequency is less than f, with which it is rotating. Okay, so what are the forces which are acting on this? So downward force, what is that? mg. Upward force, what is that? Frictional force, capital F. Yes, I will write down. Frequency with which, okay, frequency I will take f. So this block will fall down if rotation frequency is less than f. Till there, what happens? It will just match together. What is that? The block will be attached to this surface. So when it is attached to surface, what are the forces which are present there? One is frictional force and weight towards downward, because acceleration due to gravity. That is a diagram. Blocks remains in constant contact with the inner wall. The frequency of rotation is f. If it is less, the block will fall down. The coefficient of friction between the block and the cylinder is coefficient of friction between the block and the cylinder. Coefficient of friction, that means here. That is what you are going to find out. So let me write down that directly. What is that? Right now, because of this rotation, this will be applying pressure on the wall. No, while applying pressure on the wall, what will be there? There will be a normal reaction. Correct? So what is that normal reaction now? That is n equal to m omega square r. I will write down. Correct? Force equal to m into a. What is that a? Because of that is inside centripetal acceleration towards the center, right? So that is what I have written here. So what is that? Into radius, capital R. So radius value also you know. So what is that frictional force? I will just write down. Yes, Fs equal to mu into n. So is equal to what? Fs, upward. What is equal and opposite direction? That is m into g, correct? Downward. So now what we are supposed to write? So I will just write, what is that? I'll just go on writing what is n here. That is, n means, or Fs means mu into n. N means what? M omega square r. So mu m omega square r equal to m into g. Am I right? Just by looking at these two equations, I can just make out directly. So what is this? Normal reaction, correct. But what is equivalent to normal reaction? Yes, centripetal acceleration along with that. F is equal to m into a. A means centripetal acceleration. That is what equivalent to the normal. So what is that frictional force? Mu into n. Equal to mg. Why? Because downward force. What is that? Weight. Now, like this I have written, just substituting the equations. So finally, I want what? Mu equal to, this m cancels. So what remains? Mu equal to g by omega square r we get. So whether our, now this one, what is that? Options are there. So g by omega square r. So omega square r. But here, such option is not there. But we know one thing. What is that? Omega equal to 2 pi f, correct? So omega square means 4 pi square f square. So answer is mu equal to g by 4 pi square f square r. See? This is how we can solve. So direct answer is not mentioned. Some alternate we have to find out. So this is the answer what we get. Hope you understood this. Let me move to question number 8. Have a proper look on the question number 7. Proper substitutions I have done here, and finally we got the coefficient of friction here, and it is formed written in some other form, not directly like this. Yes, that is the answer. So let us go for question number 8. Question number 8 is a ball of mass 500 grams. A ball is there, mass 500 gram, is tied to one string, is revolved in a horizontal circle of radius 10 centimeter. Okay, so it is revolved. String is there. It is revolved like this. String of radius, how much is that? It is 10 centimeter. So this is the radius with the speed 1 by pi. Okay, it is given 1 by pi. So 1 by pi revolution per second it is given. That means n equal to 1 by pi RPS it is. In a gravity free space, that means gravitational pull is not there, okay? Then the linear velocity, acceleration, tension in the string. Linear velocity, V equal to how much? Next, acceleration, AC equal to how much? Next, tension in the string, T equal to how much? So these are the questions which is to be found out. So what is the, let us just go on writing down the formulas, okay? Before that, let me just find out, because frequency we know, right? So what is omega now? Omega equal to 2 pi f. But what is f here? Yes, 1 by pi. So this is 2 pi into 1 by pi. So answer is 2 radian per second. Which one? Omega. Next, by using this omega concept, what we are supposed to find out? We can find out the linear velocity. What is linear velocity? Linear velocity is given by, what's the relation between linear velocity and angular velocity? R omega. What is R? Radius 10 centimeter. That means 0.1. What is omega? 2. Answer is what? 0.2 meter per second. What is this? Linear velocity. Next, what else we can find out? Angular acceleration. Centripetal acceleration. What is that? A equal to omega square R we have. So what is omega square? Omega square is 4 into R is how much? 0.1. So this is 0.4 meter per second square. Am I right? Next, we require tension. Tension in the string will be equivalent to what? Into the force which is actually directed towards the center. So I can write what? M into A. What A? A means acceleration. That is omega square R. So this is mass. Mass is how much? 500 gram. That means 0.5 into omega square. That is 4. R is how much? 0.1. Finally, the answer is, so this is how much? 2. 2 into 0.1 is 0.2 Newton tension. So final answer is which one? Option C. So altogether we found out the different physical quantities for a ball of mass 500 grams which is kept or tied to one of the string of centimeter. How much centimeter length? 10 centimeter. Yes, that is how we do. Okay, do it. Okay, fine. So let us go for the next question. Question number 9. Question number 9 says, 3 identical particles are joined together by a thread dash shown. Okay, let us draw the diagram like this. One mass here, one more mass somewhere here, one more mass at the end. And this is the origin. So this is, length is L, this length is 2L from this one, this length is 3 times L from this point. So let us see, 3 identical particles are joined together by a thread dash shown. 3 identical, that means all are having the same mass, m. Correct. All 3 particles are moving with the horizontal plane. That means all 3 are moving All three particles are moving in a horizontal plane. That means they are moving. Okay, all three particles. If the velocity of the outermost particle is v naught, then the ratio of tension in the three sections of the string is, that means velocity of the outermost particle is v naught. They have given outermost particle. What is that outermost particle? This one. Its velocity is how much? V naught, with which it is moving. Then the ratio of tension in the three section of the string is, that means T1 is to T2 is to T3 equal to how much? But where we can find out the tensions here? So tensions in the diagram you can see. Okay, carefully have a look. We are just, imagine we are pulling this, okay, like this. While pulling, what happens? Here one tension develops, its equivalent tension will be like this. Because of this particle also there will be a tension, there will be a tension. Because of this particle also there will be a tension like this. Correct? Now, this tension I will take T1, then here what is the tension which exists? T2, correct? So this will be T2, this will be T3, this will be T3. Single string, individual string. So this is how we can draw. From laws of motion, free body diagram, you know, right, how to draw the, okay, understand the tension concept here. So T1, T2, T3, how they are acting on this string in between the particles, I have drawn there. So now there, right now, what's happening there in the question they have asked? They have mentioned clearly there, correct? You can see there. What is that? Yeah, if the velocity of the outermost particle is v naught, then the ratio of tension in the three sections of this, because they are moving horizontally, because they have given that is moving in a horizontal plane. So what we do? They are moving, right? So while moving means, yes, we can understand. So if I take direction in the sense how they are moving, because right now it is circular motion concept. So moving in the sense, I will just take a direction like this. This one has origin, so moving like this. So it forms a circular path. Understanding? Like this. Like this. Understanding, right? So all these are actually in the same positions, in the sense 1, 2, 3, like this. So if this moves, this moves, this moves, always there should be having the same what? Angular velocity omega. So angular velocity omega and then I will just check which one is higher here. This one will be like T1 minus T2, force equal to what? M into A. A means what? Omega square R. R in the sense, what is the distance here? Yes. So T1 minus T2 is there. Next, T2 minus T3 equal to how much? T2 minus T3 is equal to, yes, omega square. What is the distance between them? L plus 2L. Total 3L, correct? From here to here. 2L plus L, 3L. Last, T3. Because one more T4 is not there. This is the end. Like this. Because nothing is there to subtract again. T3 minus T4. Nothing is there. So T3 is equal to how much? That is M omega square. L plus 2L, 3L. Again 3L. Total 6L. Like this I got. Now what I do? I will just substitute. So by substituting, what we can understand from this is, we can equate. So T2 you have to get somewhere around 9 M omega square. T1 you will get 10 M omega square. L you will get T3. Yes, of course. How much is that? 6 M omega square L. Already it is there. So T2 you have to just substitute. So now here it is. L is there. Okay. Yeah. So T3 we know, T2 we know, T1 we know. So these are actually in which ratio? So you can check the answers now. So in the answers, whether they have given in T1, T2, T3 ratios or Look at there. So ratio of the tension in 3 sections of string is. So right now, already we have given. What is that? Here, T1, T2, T3 we have found out. Here I have written T1 is to T2 is to T3 I have written. So look at that. So T1 is how much? 10 it is. So how we are supposed to take now? So here options they have given in outermost, slightly in, and again in. So right now we have taken, yes, how they like this also you can take, or you can go for what? The one more. What is that? One more type, because in the options they have mentioned like that, correct? Because they didn't mention like this from T1 is to T3 or T3, because we have to just text. That means I have to see the questions there. So this will be how much? Sorry, T3 how much? T3 will be, yeah, T3 is, yes, 6. 6 is to T2 is how much? That is 9 is to 10. So this is the answer. Answer for which one? Answer for question number 9. So question number 9 is over. I think it is easy to understand for you people which and all the forces are there which are acted on that particular string of the particle which is present there in this particular. Okay, you have a look there. Yes, next let us go for question number 10. Question number 10 I will read. A stone is moved in a horizontal circle of radius 4 cm by means of a string at a height of 20 meter above the ground. The string breaks, particle flies off horizontally. Okay, so this is the ground at a height of how much? What is that? Circle of radius 4 centimeter. Okay, height of 20 meter. Okay, that means y direction. This is 20 meter. Circle of radius. That is x I will take. This is y. So it was rotating, suddenly it gets cut. So this is the direction V, it falls like this, correct? Which one? The stone. So the string breaks and the particle flies off the, particle, it is not stone, horizontally, strikes the ground 10 meter away. So that means, what is the, yes, of course, you know, what this range is 10 meter away. The centripetal acceleration during the circular motion is. So right now it is parabolic path, am I right? So let us just note down what and all they have given there. So right now y value they have given, that is 20. X value they have given, range, how much is that? It is going to take around 10 meter. Next, what else they have mentioned? They have mentioned y value, x value, v value we don't know. Now it is parabola, and you might be remembering the previous P03 or P02 I think we have discussed something regarding motion in a plane. In that motion in a plane we have come across the equation for parabola. Right now by looking at this one, okay, so what you can understand is we can frame the equation y is equal to gx square by 2v square. This formula you might be remembering. By using this, what I do is I will just substitute here. When the motion in a plane, this concept comes. Shortcut formulas. G is 10. Next, x square is, x is 10 square divided by 2v square. With what velocity? We don't know. We have to find out. So centripetal acceleration during the circular motion. Centripetal acceleration we want. So that means first let us find out what is v. So v will be, after substituting this, v you have to get somewhere around, check your answer, around 25 meter per second. That means v square equal to 25 meter per second. So now we know what is a equal to v square by r. So a equal to, after substituting, radius how much? Radius of that circular this thing's radius, okay, it was 4 meters, so it is 25 by 4 is equal to, is how much is the answer? 6.25 meter per second square. So that is the answer. Answer for which one? Question number 10. So question number 10 is over. Let us go for question number 11. So question number 10, I think this is easy for you and you understood very clearly. Substitutions I have done in detail. You can check what are the formulas I have used. Next, question number 11. Question is, a particle of mass m, diagram is given there like this, tied to a light string of length L, like this, then moving on a horizontal circle of radius r. So that means it is like this, it is moving. This is theta. The force acting on the particle R, mg and T. Okay, correct, because tension T, downward mg. Oh, yes, they are acted, correct. Next, they have given mg T mv square by R directed inward. Okay, let us see, okay. mg T mv square by R directed outward, not possible, of course. mv square by R only, that means only centripetal force, no, of course. That means we know directly, we can see here it's like a simple pendulum, but it is revolving. So tension is there, mg is there, correct. But whether force is there, that means centripetal force is there. Always remember, centripetal force is not, okay, here centripetal force is not a new kind of force. Understanding, right? So here in this currently what we can say is centripetal force is not a new kind of force. Force acting towards the, it's a force just acting towards the center, which is common, which is present in all kind of circular motions. So now, right now this is revolving like this. What are the actual forces which are acting on this? Suppose it is asked. It means, remember always, it is just mg downward, T upward, and it's naturally occurring kind of force, that is centripetal force. No need of again taking that, you see, mv square by R also it is there like that. So it is not a new kind of force which will suddenly occur here, it's always present there. So what is the main forces which are acting here is on the particle, that particle force is tension as well as mg. So option is A. Mg and T, tension and weight of that particle. Next, question number 12. So question number 12, what is there? Let us see. In the previous problem, if T is the time period of the rotation, here, time period of rotation means, you know, right? Yes. So if time period of rotation, so options they have mentioned there. So what we are supposed to do now, let us see. So here they have given, what is that? Here what you are supposed to find out here, what is the time period? T equal to how much? In previous problem, what is previous problem? 11th is the previous problem. Okay. So now what I write is, I will just take this again separately here. This particle, suppose you just split into component, this becomes what? T cos theta. This becomes T sin theta, correct? This is T, like this. So T cos theta, which is opposite? mg. T sin theta, what is that? Force. So what is that force now? Yeah, so I will take, what is that? M omega square R. So what I can write? T cos theta, I think it is visible for you people. T cos theta equal to mg. So T equal to mg divided by cos theta, I will write down. Next, what else is there? T sin theta is equal to ma. What is a? Omega square r, centripetal acceleration. So in this case, sin theta, see r is there, right? R means what? That radius here, this side. This radius, we don't know what is the value, but we know what is the length of this, that is the L. So you can write down this one as like this also, correct? Sine theta, opposite side by hypotenuse, like that if you write means square r, omega square into, in the place of r, what you can write is L sine theta also you can write down. Because sine theta equal to what? Sine theta equal to opposite side by, yes, hypotenuse. What is opposite side? Don't know. What is this? R. This is L. So opposite side by hypotenuse. What is opposite side? Sine theta L. Okay. So sine theta we can cancel there. So T will be written as m omega square L. So tension value we got to know. What is that tension value? M omega square L I got. So I will continue here. So next, what I do is, I got to know what is, value of this one tension and all. So these two equations are equal now, correct? That means mg divided by cos theta equals to, what is that? M omega square L. M omega square L we have. So this one cancels, correct? You can see there. Now what you can write? You can write what? What is omega you can write? So omega equal to what now? This is square root of g by cos theta L. Like this you will get. So g by L cos theta or cos theta L you get. But what about time period? Time period means we know T equal to 2 pi. Now what is that? There is something. So what is that? 2 pi by omega, because it is reciprocal of frequency. So what we can write? This is 2 pi into L cos theta divided by g. This is the answer now. Whether we are having the same option in the given options there? No, we don't have. So we have there, but the options is not direct because sub answers are there, like 1 and 2, 2 and 3, something like that. So now again what we do, I'll just write down this once again. What is that? T equal to m omega square L, right? So m into, what is omega? Omega square, that means 4 pi square divided by T square. See? Rearrangement of this. Small t I have written just for the purpose of not making you confused. And what remains here? L remains. So, time period, one equation I got here. And I have to compare with one more also, because the question is like that. You can see there. Okay. So, like this I got. Finally, what I can write from this is 4 pi square m by t square I can write. Correct? L is also there. So now, what is the option that is possible now? Option which is possible is, that is, what is that? Question number 12. So option is B. So option is B, which is suitable here. Okay? Yes. So next is question number 13. Okay. So question number 13. I will do it here. I think it is clear for you. Take down neatly. In detail, I have written the substitutions and the formulas which are to be used. Okay. So next is question number 13. So question number 13. Let us start. In question number 13, a tube of length L, a tube is there, like this, filled completely with an incompressible liquid of mass capital M, closed at both ends. So inside this tube, some liquid is there, incompressible. Tube is then rotated in a horizontal plane about one of its ends. I will take this one as fixed positions. It is rotated. Okay, it is rotated. So like this, I'll take omega. Next, what else is there? The tube is then rotated horizontally on the plane about one of the ends in uniform angular velocity omega. Yes, I have shown here omega. The force exerted by the liquid at the other end is. That means inside this one liquid is there, right? The other end, what is the force exerted by the liquid inside this? Because when we start rotating, no, the liquid is there, no, it will exert some force inside this. So I will take a small portion of this, which one is dx, okay? And total length of this one is L, which one? That tube. That is the length. So now, I don't know from how to find out directly. That is why I will just go for the basics. I will take a small distance x, unknown distance x, from the element dx. Then I want to do what? Linear mass density I will write down. Entire fluid we cannot find out directly. That is why small portion liquid I will take, and linear mass density of that I will write down. That is dm equal to, what is that? Mass per unit length, right? So entire mass divided by entire length into, what is that? That small element length, that is dx. So now it will give dm. That means linear mass density of the small element dx. So what is the force exerted in that particular area or that particular position? That is df equal to, what is that? df means, mass into acceleration. That means dm into omega square r. R means what? Distance from position to this point. What is that? Yes. Hope now you are understanding this properly. Now what I do is I will just go for the integration. So integrating, now taking this integration means how to understand this very clearly. That is dm. dm means, you know, right, m by l. Omega square is there. Integration of x dx. From where to where? It is from, now it is only small. From where to where we want? Entire liquid. That means column we want. So L. So it is L I will take. So this step I have directly written integration, because you are very familiar with the integration now. So I have taken a small element dx where I am going to do the integration by using that entire column, which is completely filled with incompressible liquid. I want the force exerted by that one to the end of this because of its rotation. Okay. So we have written like that. Next, when you start integrating this, what you get is, yes, integrating on the both sides. So f equal like this we get. So m omega square by l, integration of x square by 2, 0 to L, like this you get. So what is the answer now? Half m omega square, L square, here L is there, cancels, so L remains. So this is the answer. So the incompressible liquid is there, right, inside that. So how much pressure, in the sense force, that is exerting on the end of this particularly, what is that, column, we got to know. Yes, that is half m omega square L. So that is the answer now. So that is all about question number 13. Okay.